Hello, today we're going to be looking at proportional relationships, understanding what a proportional relationship is, what it means, and then applying that a little bit. So if we look at our question, is the relationship between the number of tickets sold and the number of hours proportional for concert A and for concert B? Okay, so let's zoom in on this word proportional for a minute. Okay, proportional means that when we take, one way we define it is when we take the ratio of my y values divided by my x values, all those ratios need to be equivalent for every single pair of values. So we're going to first look at concert A and then do it for concert B. Okay, so now we're going to look at concert A. So what I'm going to do is I'm actually just going to extend my table to have a last column where I find the y value divided by my x value, the ratio of y to x. Okay, and we're told here that our y is going to be our tickets sold. So I'm going to find my y, and I'm going to divide that by my x value. Generally, our y value, that's going to be our dependent variable. So that's going to be like the outcome, something we don't have control over. And our x is going to be our independent variable, something we do have control over. So I can control if I'm like a concert venue. I can control how many hours I sell tickets, but I can't control how many people actually come and buy them. So my x here, that's why it's my independence, my x, my hours. Okay, so for each set of these relationships between our two quantities, hours and tickets sold, I'm going to find my ratio, y divided by x. Okay, so for my first one, I'm told after 2 hours, I've sold 16 tickets. Okay, so 16 is that y, and that took 2 hours. So my ratio is 16 divided by 2, 16 over 2. Okay, then I'm going to do the same thing for my next set. After 3 hours, I've sold 24 tickets. So I can do 24 divided by 3. Okay, for my third set, I have 48 tickets sold after 6 hours. So I get 48 divided by 6. And then lastly, I get 68 tickets sold after 8.5 hours. All right, we need to simplify, find the equivalent ratio. For our first one, we have 16 divided by 2, or 16 over 2. So that's going to be equivalent or equal to 8 over 1, 8 divided by 1. 16 divided by 2 is 8, 2 divided by 2 is 1. Or if we were to just divide, what does this say? This says 16 divided by, because a fraction requires division, 2. So 16 divided by 2 is 8. Okay, then I can do the same thing here. I have 24 divided by 3. If I want to simplify that, that's going to be equivalent in a fraction form to 8 over 1. 8 divided by 1. 24 divided by 3 is 8. 3 divided by 3 is 1. Or you just think of it, 24 divided by 3. What do we get when we do 24 divided by 3? 8. Okay, so same thing here. 48 divided by 6. 48 divided by 6 is 8. That is also going to be equivalent to 8 over 1. And then lastly, I have 68 divided by 8.5. 8, right? And that's also going to be equivalent to 8 divided by 1. 8.5 divided by 8.5 is 1, and 68 divided by 8.5 is 8. Every ratio I got for y divided by x is equivalent to 8. So are these ratios equivalent? Yes, yes. Okay? So that means that I do have a proportional relationship. So I'm just going to type that up because we always, for a word problem, want to have a nice clear answer. There is a proportional relationship between the number of tickets sold and the number of hours for concert A because the ratios of y to x are all equivalent. Now let's take a look at concert B. All right, so here we are set up for concert B. So we have the same situation. Y is going to be my dependent variable, the number of tickets sold, and x is hours, the independent variable, what I can control. We need to find the ratio from y to x for each of my 4 pairs of quantities that I have, pairs of values. Okay, so for the first one, after 1 hour, I've sold 5 tickets, so 5 is going to go in my numerator because it's my y value, divided by 1. Okay, then I'm going to do the same thing here. I have 14 tickets are sold every 3 hours. Then I have 26 tickets are sold, 5.2 hours. And then lastly, I have that 30 tickets were sold in 8 hours. Okay, and these are my ratios, y to x for each of them, and I need to figure out, are these all equivalent to each other? Are these equivalent ratios? So we can do that by dividing and figuring out the value. Okay, so 5 divided by 1 is 5. We should know that, right? 5 divided by 1, any number divided by 1 is just itself. So we're going to get 5 there. 14 divided by 3, though, that is not going to give us 5. If you do on a calculator, you get 4.6 repeating, which is, this is going to be 4 2/3. That is not 5, but let's keep going. 26 divided by 5.2 is 5. 30 divided by 8 is going to be 3.75. Is there a proportional relationship between tickets sold and hours for concert B? Are the ratios, every single ratio, are they all equivalent to each other? And the answer is no here. It doesn't matter that our first and our third lines, that those are equivalent. It needs to be the case for every single one. So even if we just have one that's not equivalent to a different one, then we know right off the bat there, we do not have a proportional relationship. There is not a proportional relationship between the number of tickets sold and the number of hours for concert B because the ratio of y to x are not all equivalent. Right, so I just copied and pasted and added in not because that's really the difference. Proportional relationships, the ratio is the same for every pair, and for non-proportional, then that's not the case. So now we're going to look at an example. Are x and y proportional? And then we're told if so, we need to find y when x equals 7. So first, let's figure out if x and y are proportional, again, by finding that y divided by x. Okay, so for the first one, my y value is 16. My x value is 2. For my second one, I have that my y value is 24. My x value is 3. And then for my third one, I have my y value is 48. And my x value is 6. So we have 16 divided by 2. 16 divided by 2, that is equal to 8. Then we have 24 divided by 3, that is also equal to 8. And then we have 48 divided by 6. That is also equal to 8. Okay, so we can go back to normal. Are these proportional? Yes. X and y are proportional because their ratios, x, y, are equivalent, are all equivalent, and equal to 8. We're going to see a few ways in the next few days to determine then what is the value of y when x equals 7. Okay, so we're going to look at 2 ways today. So the first thing is we can try to set up what's called a proportion. So a proportion is when we have 2 equal ratios, an equation of 2 equivalent ratios. Since we know, okay, we're going to do that by creating a proportion. So since we know this is a proportional relationship, we know that any 2 ratios of y divided by x have to be equal to each other, and they have to be equal to 8 in this case, right? They're going to be equal to each other. So I'm going to pick one pair. Let's see, I have my first one, have 16 divided by 2. That needs to be equal to then any other set. Okay, so again, my y values are in my numerator, and my x values are in that denominator. So they're telling me find y when x equals 7. So if I look at my table, I don't know what the y value is when x equals 7. We have 2, 3, and 6. None of those are 7. Okay, but I can set up this proportion to figure it out. Right, so like if I had 7 here, what would be the y that goes with it? Well, in either case, 7 is going to be on that denominator, right? And then we need to figure out what the y is. So we're just going to use a variable. We're going to call that y. right? That's our missing y value. Okay, and now we have a few ways to solve this. So one way is like we've kind of been doing the past few days, is thinking about equivalent ratios, looking at our denominators. I get from 2 to 7 by either multiplying or dividing. That's how I would do this if these were, if 2 and 7, if 7 was a multiple of 2. But what's hard about this is 2 isn't a multiple, 7 isn't a multiple of 2. So what we could do is we could figure out, okay, 2 times some missing value has to equal 7. Well, that's like an equation, kind of. That's like 2 times x equals 7. And then I have x times 2. How do you undo multiplying by 2? We divide by 2. So we get that x equals 3.5. But that's kind of all tangential work. That what I'm figuring out there is that 2 times 3.5 equals 7. And what I'm really doing is I'm doing this 7 divided by 2. Right? When I do 7 divided by 2, I get 3.5. Thus, 2 times 3.5 equals 7. Okay, so then I could find my missing y value up here. I could find y by doing the same sort of thing. I can do 16 times 3.5, and that will give me my correct y value when I do 16 times 3.5. So 16 times 3.5, that is 56. So that means I'm going to have 56 right here. That is true that 56 divided by 7 is equal to 8. Okay, so that's going to work. Okay, so that's one method. Another method is going about this in like solving the equation that we just wrote. So we did already review equations, but it's something that it takes a lot of time to really get comfortable with. But if I'm looking at this situation, what I have is I'm told that y is currently being divided by 7. And then that's equal to 16 divided by 2, which we know is 8, right? Y is being divided by 7. So I need to ask myself, okay, right now my variable y is being divided by 7. How do I undo dividing by 7? You undo dividing by 7 by multiplying by 7, right? So I'm going to then multiply this side by 7, multiply this side by 7, and when I do that, I'm just left with that y here on the right-hand side, because dividing by 7 and multiplying by 7, we can cancel these away, right? That's just like 1, so it all goes away. And then here we have 7 times 16 divided by 2, which we know is 7 times 8, and 7 times 8 is 56. So that is why y is equal to 56. Okay, so again, what I did, I looked at that original equation I had written, and I saw that in this situation, my y, my variable, was being divided by 7. So we can undo that by multiplying by 7. Right? And then we go on and solve. Okay, so either way, we get 56.